answer.
Set. Hello, Assalamualaikum. Testing dengar.
Waalaikumsalam, Sir.
Salam. Dengar. Okay.
Dengar.
Alright. Ya. Device setting tak boleh pakai setting ada. Okay. Boleh pakai.
Hello, my name is Farisa Atika binti Muhammad Jani. My name identity is number 4. I'm calling from ITT440 28 June 9:50 AM.
Assalamualaikum, my name is Shazari binti Muhammad Akbar, number 22. Please log in ITT440 at 9:51 on 28 June. Thank you. Log in ITT440, Nurida Husnida binti Muhammad Hairi, 19 on the list. Log in at 9:52 AM on 28 of June 2021.
Assalamualaikum, my name is Nur Azmar binti Syahrum Azlan. I am number 16 on the list. Log in for ITT440 at 9:54 on 28 June.
Assalamualaikum, my name is Siti Anisa Fisa binti Muhammad Khori, number 21 in the list. Log in for ITT440 at 4 AM on 28 June 2021.
Log in ITT440 Nur Atira binti Rahman, number 17, 28 June 2021 at 9:56 AM.
Log in ITT440 Nur Sabira binti Allah, number 18 on the list. 28 June 2021, 9:56 AM.
Good morning, this is Stanley, number 22 in the list, logging in for ITT440 at 9:57 AM on 28th of June 2021.
Assalamualaikum, my name is Shahida Najia binti Shariza, number 20 on the list. Log in for ITT440 at 9:55 AM on 28 June 2021.
Assalamualaikum, my name is Raja Zani binti Muhammad Rosi. I'm number 3 on the list. Log in for ITT440 at 9:58 AM on 28 June 2021.
clock in ITT440 Ahmad Faiz Wafi bin Azhari, position number 1 in the list, 28th of June 2021 at 9:58 AM.
Clock in Asal
ITT440, my name is Muhammad Shakir, rising number 12 in the list. 28 June at 10 to 8.
Assalamualaikum, my name is Naimi Shazali binti Nariman. I am number 14 in the list. Clock in for ITT440 at 10:03 AM on 28 June 2021.
Assalamualaikum and good morning. My name is Sutika Sarashmi Tijumani, number 24 in the attendance. Clock in for ITT440 at 10:05 AM on 28 June 2021.
Log in ITT440 Muhammad Abdul Hakim bin Muhammad Amiruddin, number 6, date 28 of June 2021, time 10:06 AM.
Assalamualaikum, nama Zanain, number 50 on the list, calling for ITT440 at 10:06 AM on 28 June 2021.
Sir,
Ya.
nama saya dah clock in tadi tapi saya tak tanda.
Oh, tak tanda. Nombor?
Sikit, nombor 18.
18. Ni siapa lagi?
Kira.
Sama.
Assalamualaikum warahmatullahi wabarakatuh. My name is Awati binti Jasin, number 2 in the list, ITT440. I clock in at 10:07 AM, 28 June 2021.
Alright. So let's record. Wait lah. Alright. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil sayyidina wal mursalin wa ala alihi wa sahbihi ajma'in. Subhanaka la ilma lana illa ma 'allamtana innaka antal alimul hakim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Wala hawla wala quwwata illa billahil 'aliyil 'azim. Allahumma shalli ala sayyidina Muhammadin wa ala alihi wa sahbihi wasallam. Assalamualaikum warahmatullahi. And very good morning. So let's we answer the first question for today. Okay, I share screen . I'm sharing my screen. Where is Windows share? Okay. Can you see my screen?
Yes, sir.
Yes. Okay. Please open your browser. Mana tak nampak ni? Okay, Go to menti.com, use code 32140725. The first answer, the feeling of affection. Don't use Google Please don't use Google. Answer based on your opinion. What is a love? Mana nak check dalam team? Microphone. Dr. Alia, use microphone. Can you hear me? Love is blind. No. Dak, bagi tahu. Macam mana nak chat? Chat, oh nak chat dalam ni. Chat ada dekat ni. Sagi. Lepas chat lagi. Ni cara kami chat ni. Ingatkan chat cakap kan. Okay, love is trust, love is blind, love care each other, the feeling of affection, care, spending money on food. Really? Love is emotion. Love is apa? Trust. Love is something wrong. why love is something wrong? Okay, can you give a reason why you put love is something wrong? Answer on here. Reply. Here we can chat here. Why love is something wrong? Chat here, Love is cinta. I don't know. Why you don't know? Why you don't know? Why you don't know? Why you don't know? Why you said food? Please answer. Answer on chat box also. Trust, happiness, beauty before attitude. Love is respect or passion. Okay. Again. A strong feeling. Okay. Love something wrong. This is something wrong lah. Love eat cats. Do you love your cats? Love based on quality. Okay, so it will go to the second question. Alright. So wait. Happiness. Okay, happiness. Respect. Dah kan. And everything. Let everything positive. Right. Okay, so the second question we'll ask is love is family. Yeah, love is kasih sayang bahasa Melayu lah. The feeling of affection tadi dah kan. Sharing, yes, sharing. Love is sharing. Alright. So let's move to the second question. Wait, Which one? Let me put this. Still answering, and snatch. New. Okay. Reply. Another reply. Control V. Okay. Enter. Wait, ah. Can you see my screen? Cannot, right?
Cannot.
What do you... Okay. This is a second question regarding love. Ta-da! Alright. No. Sorry. I should put another screen. Technical error. Wait lah. Kali lagi. My computer going slow down ah. Wait. The same question. You can think about the answer. Then I put a new slide. Okay, here. Okay, semula. Again, the same question, and then answer on your menti.com. Do you know ITT440 is a tough one?
Yes, sir.
Yeah. So, no, about our course. What do you love? Is it programming? Is it a socket programming? The challenge is not because me lah. Do you love about a new language? Not because me lah. I asked you about ITT440. Okay, you love to challenge yourself, right? Oh, you should get a new one, M1 laptop. Do you love programming, right? Good. Another answer? Come on, guys. Oh, error. You love about error. Me too love error. Because error make me do a right thing, right? Yes, because 440 is... Yeah, but child and parent, fork. You can fork your program, man. Before this, you don't know how to fork. Yeah, you got it. Alright, so we have no final exam, but we have a final assessment. You must go into that final assessment. Oh, because you love network programming. Right, so you can use this as in your future. Right? So manfaatkan ilmu, right? Knowledge. Any other question? Any other answer? Alright, actually, while we have a tough subject to learn this semester, we must create something enjoyable moment, because this is what we can go we can facing the challenges through this semester. Alright, so you must motivate yourself. Okay, yeah. Okay, the repeat again because no final exam. Alright. Okay, so we go to our chapter today. We are still in the topic chapter 8. Okay, parallel. Okay, but I have something to you to recall back the parallel. Where am I? Thank you for answering the love question. Okay, let's learn back on this YouTube. Where my share screen? I must share screen with include computer sound. Alright. Okay, let's see this chapter 7 video. We learn previous chapter 7 Python socket programming. Can you hear this? Okay.
Now, an important thing that we need to do is actually handle how to close a connection. So we want to make sure that when a client leaves, there's some protocol that we've come up with to make sure that we handle their disconnection cleanly.
Okay, can you hear that?
Yeah.
What he's talking about? You want to close the connection, right? You want to write the connection, close connection part, okay, on the syntax.
So yes, they could just disconnect and not tell the server that they're disconnecting. That wouldn't really cause that many issues. But when they want to reconnect later, we might run into a problem that the server already has them connected, and since they didn't cleanly disconnect, when they try to connect, it's going to say, hey, we can't connect you because on our end, it seems like you're already connected, even though they may not be. So the way that we do this is we come up with some kind of message that we send to notify the server that we're going to disconnect. So in this case, we're going to call this the disconnect underscore message, and we're just going to make this a exclamation point and then disconnect. Now you can make this message whatever you want, but this means when we receive this message, we will close the connection and disconnect the client from the server. So to do that, we're going to say if here, so if msg equals disconnect message, then we'll simply say break, or we can say connected equals false, right? We can do whatever one we want. I'll just do connected equals false. And then, yeah, we can print out the disconnect message, that's fine. Then what we're going to say is con.close. What that means is close the current connection, cleanly disconnect, everything should work fine. And in fact, yeah, that should actually be fine. And I think that might be the server completed. Let me just look and make sure that everything is fine here. I believe it actually is. And we're good to go. Alright, so this is the server. The server is complete. Let me show you what happens when I run it.
Okay. Now the server script, the server coding is complete. Do you agree? Do you agree? Where's chatting box? Where's chatting box? Yeah. Oh. Okay. I put a new conversation. So the server for Python socket programming now complete. Okay, can you spot the parallel there? Okay, Can you spot the parallel computing on this socket programming in Python? Possible. Which line? You can just put a which line? Line number 1 until 22. Which line is parallel? Do we have an answer? Still no. Come on, guys. Please answer. Which line? Which line? We have 1 until 22. Forget it. Forget about 23 below. So there we can spot parallel actually. Parallel computing. Which line? Please answer. Please answer. Kalau tak tahu pun tembak. Come on guys. Jawab dekat chat. Answer on chat box. Dah setengah jam belum? Seminit lagi. Then we come up with slide 10:30. Come on guys. Okay, 1 minute. Okay, 12 server.bind. Okay, it's not really parallel. Okay. Thank you Atira for answer. I tahu you tembak je. Lain. Lain tembak cepat. Seminit ni. Saya nak masuk we go to slide 15. No. Not parallel. 11 semua line kamu tembak. 11 no. 11 is socket programming. 20 no. But close one. Nice try. Thank you. Again 7 no. Come on 16 16 is no parallel there. Twenty-two no. Tak jumpa lah. Answer dah 10:30. Okay, 10:30. Tak ada jawapan. The answer is tak ada siapa betul lah.
And we're good to go. Alright, so this is the
server.
Server is complete.
The answer is the answer is 31 and 32. Please clap for Sir. Jawapan dia 31 dan 32. Track, nampak tak? 31 and 31st and 32nd. Tak ada siapa betul lah. Okay, so memanglah sebab saya tak tunjuk kan 31, 32 kan. Saya tunjuk 1 sampai 22 je. Okay, sebenarnya ada jawapan dia kat atas tu. Okay. Okay, dekat second line, nampak? Import trading. Semua tak betul. The parallel is on library import trading. So that's why we can go to 31 and 32. So we can call the thread. Okay.
Connected equals
31
it's false, right? We do whatever one we just.
Okay. Now it's go to next 34, 35.
Everything should work.
Here 34 and 35, right? Thread. So the answer actually on line number 2, right? Okay. So that is little bit parallel in your socket programming. Actually, we done that previous. Okay, on the answer is import thread. Line number 2. Okay. So, do you have a slide? Which my slide? Forgot my slide. 440 dah tak ada slide. Kat mana saya simpan? Chapter 8. Okay. Okay, so chapter 8 parallel computing. Do you have a textbook? Because I write this slide based on the textbook. Do you have a textbook? Tak ada. Okay, so I will share my ebook. Okay. I got from my colleague. So he teach parallel. So we can use that textbook. Okay, content outline. So in this chapter we sub into 3 subtopic: introduction to parallel computing. Second one is motivating parallelism. And last is scope of parallel computing. After this chapter 8, okay, students should be able to understand the basic concept of parallel computing, where is my highlighter? This highlighter. So students should be able to understand the basic concept of parallel computing. Okay. So the term we use here there is parallel computing. Alright. So and then students should be able to identify the different scope of parallel computing. Okay. We have another term, parallel programming. Okay, parallel programming. Okay, that we see from previous Python socket programming video. That is a parallel programming. This is a parallel programming. Okay. Okay, so let's answer the next question on menti.com. Welcome. Where is menti.com? Menti.com. The second question. Which is this is? Okay, present. Okay. Go to menti.com and use the code 32140725. Answer which is one is parallel computing. Okay. We got a multiple process. This one agak dia tak ada orang jawab. 12. Okay, let me see your answer first, then we go to the slide. Then you know the real answer is what. Okay, we got one. Alright. Boleh, boleh. Boleh. No problem. Okay. So, siapa yang belum answer, you can take this on background. So, we go to I must finish all class with recording with you all, guys. So, please stay tuned. Use English until finish our class today. Alright, so where is my team, Microsoft team here? No. Mana team yang lain? This team general, I put the ebook there. Chapter 9, chapter 8, right? Chapter 8, class material. On chapter 8, there is uploading. Okay, uploading one item. Okay, uploaded the ebook. Can't you open it? Okay, this is introduction to parallel computing textbook by Anas Grammar Anas Grammar, Anshul Gupta, Josh Karips, Vipin Kumar. Edison Wesley, January 16, 2013. Okay. So the first word is increasingly parallel processing being seen as the only cost-effective method for the fast solution of computational large and data-intensive problem. So we look here, parallel computing is cost-effective. That means we save a lot of lot of money instead of we use multiple. Not multiple. We use a large CPU, large memory, large other processing. So we can use a parallel processing to become a method for solution of computational large and data intensive problem. Right? So you can read there this set of stage substantial growth parallel software. So actually on matikah aku mana cari tak jumpa dah. Blackboard saya ada blackboard. Ini whiteboard tapi saya tukar dia jadi blackboard. Buka banyak-banyak ni slow lah komputer. Actually kena tambah lagi parallel dalam processor saya kan. Okay, this is my blackboard. So if you look there, so we can see parallel software there, right? So which means we have parallel merah pula. Parallel software, and then we have parallel Kalau ada software maksudnya kita ada parallel apa? Dah senyap dah semua. Ke saya hilang daripada radar? Hardware. Alah, nak suruh jawab yang senang je. Software ada, hardware lah. Ke ada middleware? Tak pasti. Middleware tak pasti. Alright. So, parallel computing dekat mana? Okay, so kita tengok parallel computing and then parallel apa satu lagi kita jumpa tadi? Programming. Okay. So dalam programming ada apa? Ada thread kan? Dalam ni ada threading kan? Okay, hardware? Cuba try hardware. CPU yes, CPU. Ada apa dalam CPU tu? Dalam satu CPU ada apa? Processor. Yalah, dalam satu processor tu ada microprocessor tu ada apa? Parallel kan ada banyak kan? Kita panggil apa? Tak ingat dah tu. Okey, bagi saya okey, dengar apa? Yes, core CPU core. Siapa jawab tu? Thank you. Love it. Alright. So CPU core. Lain. Kadang kita tak panggil CPU core, kita ada apa? Multi-core. Yalah, multi-core. Tak, selain daripada core kita kalau dual core, one CPU, one microprocessor akan ada two CPU dalam dia kan, inside dia kan, dua dalam satu kan. Yang tu physical kan. Yang logical tu kita panggil apa? Thread. Yes, kita panggil hyper threading. Okay. So dia ada core. Okay, so kita ada core. So that's why kita ada core. So dalam core kata ada 4 kan. We have 4 multi-core, quad core, betul tak? Okay. So quad core kita akan akses ke RAM kan. Ni bus, kita ada RAM. Okay, and then kita ada apa lagi? Storage. Panjang sikit lah. Through motherboard kan. Okay, kita ada RAM. RAM kan saya nak lukis RAM macam mana lah? Itulah RAM kan. Kan. So, kita ada RAM. Itu RAM and then kita access to storage kan. Alright. Clear. Okay. And then pernah tak kita tengok ada which is dual microprocessor can put in one motherboard? Pernah tengok tak? Tak pernah. Okay, yang ni dalam server memang ada. We can put this hyper thread and dual core, quad core, multi core in single motherboard, so they can share the same RAM, okay, and the same RAM and the same IO resources, alright, in single computer. So that's also that's one we have core and hyperthread. Second one we call as SMP. Okay, SMP. Second one. Please Google SMP apa, bukan yang UiTM punya, symmetric apa, kan. So that's also parallel computing. Okay. How about GPU? Kita ada another CPU in graphic card. Is it also parallel? Yes. So kita ada parallel. Okay. So kita ada 3 dah. We have another parallel. Okay. And then we have actually we have another type, a software parallel. I cannot remember the name. F what? Okay, FRPA ke? Kan? So that is a kind of another parallel for. So nanti kita jumpa dalam buku. Okay, so and then parallel, just satu lagi kita ada distributed computing. So kita orang network patut tahu distributed computing. So this all kita akan access ke this part of computer kita, we can access through LAN. LAN, what is LAN? Apa tu? So kita ada backbone here. So we have backbone. Macam mana aku pakai backbone ni? Backbone satu line yang besar lah. Okay. And then so in LAN we have multiple computer like this. Okay, so kita ada another server, the same one. This is the same one. We call as a, dalam distributed computing we call sebagai clustering. Alright, so kita ada 5 sekarang. Right, so if involve parallel software and parallel hardware. Okay, back to our slide and textbook. Okay. Clock rate of computer processor. Ni ada dekat buku chapter 1. Coursework apa? Boleh tekan tak? Tak boleh Dah. Oh, dah terlajak Clear tak? Kamu buka tak sendiri kat tempat kamu? Download dah. Dah, okay. So pergi kat chapter 1. Go to chapter 1. Sama tak? Dengan slide. Alright, so sama kan? Okay. Saja melambat-lambatkan Sini. So the past decade has seen tremendous advance in microprocessor technology. Clock rates of processor have increased from about 40 MHz. So we have here MIPS, okay, to over 2.0 GHz Pentium 4 at 2002. At the same time, processors are now capable of executing multiple instructions in the same cycle. The average number of cycles per instruction is CPI of high-end processor has improved by roughly an order of magnitude over the past 10 years. All this translates to an increase in the peak floating point operation execution rate, or what we call flops, okay, floating point operation per second, of several order of magnitude. Flop of several order of magnitude. A variety of other issues has also become important over the same period. Perhaps the most prominent of this is ability of lack thereof of the memory system to feed data to the processor at the required rate. significant innovation in architecture and software have addressed the alleviation of bottleneck posed by the data pass and the memory. Okay, the vice versa of parallel is concurrency. Okay, concurrent system, concurrent processing. Okay, the role of concurrency in accelerating computing element has been recognized for several decades. However, their role in providing concurrent ni that mean satu processor you can use for multiple process. Ada orang jawab ni kan? Tara, one processor, multiple process. That is a concurrent computer, concurrent programming. So we learn on the first chapter kita, Unix multiprocessing ah. Okay, one processor, multiple process. Okay, however, their role in providing multiplicity of data part increase storage, blah blah blah, dah habis kan? Untuk both memory and disk, scalable performance and lower cost is reflected in the wide variety of application of parallel computing. So semua ni adalah motivated to parallel lah. Okay, so kan ni dia letak gambar sekali ya. Alright. This slide written by lecturer in Shah Alam. Okay, thanks to Mr. Azizi. Okay, processor are now capable of executing multiple instructions in the same cycle. So this is concurrent. Okay, so parallel ni terbalik. That means satu proses we can execute at the same time with multiple processor. Okay, so ada seorang je jawab. Okay, semua jawab ni sebab dia adalah normal processor. Normal processor memang boleh multiple process because we use a concurrent and parallel in the core system kita kan. Okay, tak salah. Okay, yang tepat tu yang seorang lagi lah. Okay, so idea dah hilang. Sekejap. Tunggu idea main balik. Okay, so let's take analogy. Okay, so one person can read book and eat apple at the same time. Yang ni concurrent ke? Ini concurrent ke or parallel? Concurrent kan, sebab dia boleh proses multiple proses kan. Dia seorang je, processor seorang, one processor and then multiple multiple proses kan. Okay, so what about kita put another person. So dia baca buku, dia duduk sebelah lah kan. Dia duduk sebelah. Suami isteri lah. Kalau laki-laki pun geli juga kan. Duduk sebelah kan. So suami isteri lah. Okay, so dia baca buku sambil makan apple yang sama. Kan. Ini kan multiple processor, multiple process. Is it concurrent or parallel? Or jadi N. Concurrent and parallel.
Yes.
Kamu kata yes kan? Okay. How about two person eat the one apple. Apple saya pun macam love lah. Parallel ke tak?
Parallel.
Ataupun two person read book together. Buku tak betul dah. Boleh. So actually kita tak boleh panggil dia parallel selagi dia tak bahagikan kerja. So that mean dia tak boleh makan dekat tempat yang sama. Betul tak? Apple dia tak boleh, dia kena slice. Okay, dia kena sub. Okay, kena ada sub. Macam tu juga parallel kita kena sub. So dia tak boleh baca tempat yang sama. So kita kena bahagi. Okay, so yang ni baca odd, yang ni baca even. Macam tu. So that's baru kita panggil as parallel. The keyword is parallel computing. The keyword is sub. Okay, keyword is sub. Kita kena ada sub program kat situ. Dia tak boleh makan tempat yang sama kan? Dia tak boleh baca buku yang sama. So tak guna juga baca buku sama-sama, tapi we read at the same page. Kan? So parallel, that mean one person read the odd page, one person read the even page, ataupun cara lain lah, another sub method. So janji dia bagi tugas. That is parallel computing. Boleh? Clear tak clear? Clear. So nanti boleh jawab, boleh betulkan jawapan ni. Alright, so we go to next slide. Alright, so this is a slice, kita punya slice. Nampak tak? Instruction. Okay, so serial ataupun concurrent. And then yang ni yang kita tengok last week. Then that's why you answer multiple processor, right? Okay, and then tak ada. Mana parallel? Ini. Okay, so kita kena buang dia punya pen. So we have one process, multiple processor. Okay, parallel. Oh betul, this is parallel processing. Dan kita nak tengok ada parallel computing. Soalan saya computing ke processing? Soalan saya parallel computing. So dah confuse saya kat situ. Okay, so mungkin parallel processing this one, tapi untuk for parallel computing kita kena dividekan instruction, the same instruction the same program. So we subdivide into multiple instructions. Alright, boleh ya? Confuse lagi tak? Okay, so ni dah kita dah tengok last week. Alright, so I'm skipping, betul lah? Boleh ya? Dah tak ada suara lah. Saya hilang ke? Okay, so yang ni dah kan? Ni dah kan? M1. Dah. Okay, motivating parallelism. Okay, so go to page open ni. Mana page dia? Tak ada page. Memang tak ada page je. Oh, atas ni. 13, page 13. Development of parallel software has traditionally been through of as time and effort intensive. This can be largely distributed to the inherent complexity of specifying and coordinating concurrent tasks, a lack of portable algorithm, standardized environment and software development toolkit. So saya tukarkan mode. Mana saya punya ni? Tak nampak ah. PowerPoint. PowerPoint nampak? Mana satu? Which one? Oh, ini. So, PowerPoint yang ini. Slideshow. Okay, this is slideshow. And then dekat sini stop sharing. Susah juga mainkan benda ni kan. Dia ada Windows slideshow. So kamu akan nampak. So semua orang akan nampak ini kan. Betul. Kenapa saya masih nampak PowerPoint saya? Delete. Remove. Kamu nampak saya punya screen tak?
Nampak slide je sih.
Okay. Nampak slide je. Okay, semula. Development of parallel software has traditionally been through of as time and effort intensive. This can be largely attributed to the inherent complexity of specifying and coordinating concurrent tasks, a lack of portable algorithm, standardized environment and software development toolkits. When viewed in the context of the brisk rate of development of microprocessor, one is tempted to question the need for devoting significant effort towards exploiting parallelism. Okay, ada ayat baru parallelism there as a mean of accelerating application. After all, it takes 2 years to develop a parallel application, during which time the underlying hardware or software platform has become obsolete. Okay, so tetap dia nak kena develop 2 years time period dia je kan. Okay, the development effort is clearly a waste. However, there are some unmistakable trend in hardware design which indicate that uniprocessor or implicitly parallel architecture may not be able to sustain the rate of realizable performance increment in the future. So this is a result of lack of implicit parallelism as well as other bottleneck such as the data path and the memory. At the same time, standardized hardware interfaces have reduced the turnaround time from the development of a microprocessor to a parallel machine based on the microprocessor. Furthermore, considerable progress has been made in standardization of programming environment to ensure a longer life cycle for parallel application. All this present compelling argument in favor of parallel computing platform. Okay. So the first one is flop, the computational power argument from transistor to flop. Okay, so ada quote itu from Gordon Moore, you baca dekat buku kan. So his reasoning was based on the empirical log linear relationship between device complexity and time. So they observe over 3 data point. So that's kita nak tengok apa result dia. Ada kita dapat the limit of Moore law have been the subject of extensive debate in the past few years. Okay, so ada problem dekat Moore law. Okay, so that's so they want debate on this part and staying clear of the debate, the issue translating transistor into useful OPS, operation per second, is the critical one. So it is possible to fabricate device with very large transistor count. You know kan how we use this transistor to achieve increasing rates of competition is the key architectural challenge. A logical resources to this is to rely on parallelism. So if we use parallelism both implicit and explicit, will be kita akan tengok nanti dalam next slide, parallelism. So this one of because of parallelism. Okay, this is a example. Transistor kan, dia sebut transistor. So semakin lama semakin Intel still cannot say if going to manufacture its own 7 nanometer CPU. Tak boleh kan. Makin mendesak nak pergi ke bawah lagi kan, nak kecilkan lagi kan. Semakin lama semakin kecil lah ni. Sebab dia nak semakin banyak transistor. Okay, the second argument is memory or this speed argument. Okay, the overall speed of computation is determined not just by the speed of processor, but also by the ability of the memory system to feed data to it. While clock rates of high-end processor improve or increase roughly 40% per year, okay, DRAM access time have only improved at the rate of roughly 10% per year. Tak boleh nak kejar dengan memory kan. Prosesor boleh tinggi tapi RAM tak boleh nak tinggi laju dia punya perubahan macam microprocessor. So why not they have another microprocessor, okay, share to the same memory, so that is motivating to parallelism. Okay, so because this mismatch between processor speed and data latency. So another factor is bandwidth between DRAM and processor. Okay. So the next argument, okay, ni contoh apa nama yang kata tak boleh nak kejar tu. Right. Data communication argument. So kita ada 3, okay, flops, memory and then data communication argument. Okay, so as a student networking, so kita focus on this part as the networking infrastructure involved. The vision of using the internet as one large heterogeneous parallel distributed computing, because bila sebut networking tak boleh lari daripada internet, dan internet actually is distributed computing kan. So this is environment. Okay, so we must to take shape many application lend themselves naturally to such computing paradigm. Some of the most impressive applications of massively parallel computing have been in the context of wide area distributed platform. So the SETI, Search for Extraterrestrial Intelligence project, utilized the power of a large number of home computers to analyze electromagnetic signal from outer space. Other such efforts have attempted to factor extremely large integer to solve large. So in many applications, there are constraints on the location of data and resources across the internet. So examples such as application is mining large commercial data set, distributed. Tak ada. Okay. Apa lagi? Commercial lagi apa lagi? Big data kan? Big data lagi. Machine learning, pernah dengar machine learning? AI kan? Right? Robot ada tak? Motivating to parallelism. Robotik. Ada kan? Macam mana kita nak, macam kita tengok lah. Kalau kita buat satu robot yang besar, then kita boleh tak operate dengan satu CPU je? Tak boleh kan? Kena ada dua kan? At least ada dua kan? Ada yang tiga kan? Pernah tengok robot besar? Tak pernah. Besar mana robot yang kamu pernah tengok? Takat ni. Nama robot tu Jaguar. Apa? Bukan. Jaguar. Tu Jaguar. Jaeger je nah. S-E? Y-A-E-G-E-R. Jaeger. Salah kan? Betul lah. Ni robot besar. Ada yang tiga, ada yang dua, betul tak? So dia parallel, betul tak? Tak pernah tengok ni. Processor dia kat mana?
CPU ke?
Ni kan. Ni processor dia lah. Iklan sebentar kan. So dia pakai dua processor. Kalau pakai satu je apa jadi? Berdarah hidung kan. Kalau robot kecil boleh lah. Robot kecil yang satu processor tu nama apa? Alah lupa lah. Iklan sebentar. Okay, so we go to next chapter 8, the scope. Ni kita punya application kita lah. Alright, so application parallel computing in engineering and design. Of course, kita nak guna on design. Pernah dengar rendering? Pernah dengar rendering? Rendering apa dia buat?
Dia more like exporting.
Lalunya proses rendering ni how long it takes time?
Depends on the CPU.
This depend on CPU or GPU kan? Kan? Okay. Kata a large 3D animation. Katakanlah kita pakai 3 GHz. Untuk 30 minutes 3D animation. Berapa lama kakak? Quad core. Berapa lama? Kamu kata dia depend on CPU kan?
Apa kalau quad core?
30 minit. Tak tahu. Sejam ada?
Daripada panjang video.
30 minit. 30 minutes. Dia punya lash dia 3D dia tak ada lash kan? Dia canvas kan? Katalah kita nak jadikan dia 4K. 1 jam ke lebih? Boleh lebih kan? Dia boleh pergi sampai 1 hari tak? Possible lah, nampak? That is rendering. Kan? How to overcome that? Parallel lah. Kan? Computing. Okay, so kita up GPU. So boleh tak satu komputer letak banyak GPU? Boleh. So ataupun kita pakai SMP tadi. So in one server, big server, we have a multiple slot for microprocessor in one single motherboard, or we can use clustering, kan? We can use a multiple server to render this part. Okay, last kali boleh dapat dalam setengah hari contohnya. Okay. Kalau komputer tak ada quad core, Intel Pentium 4 dulu. RAM dulu berapa? RAM dulu 1 GHz, gigabit ke gigabyte? Gigabyte, okey. RAM dulu 1 GB nak run ni. Tak ada GPU dulu, GPU tak ada. Intel dulu pun tak ada sampai 3 GB. Berapa ah? Intel 4 berapa? Intel 4 800 MHz. Boleh tak ni? Agak-agak berapa? Seminggu? Ada? Lebih kan? Silap-silap 1 bulan pun belum. 1 month pun belum siap. Punyalah dulu punya time tak boleh cater kita punya application today kan. Nak 4K. 4K pun dulu tak pernah dengar 4K, right? So, atas pada 4K ada tak? 8K? 16K pernah? 8K pernah kan? 16K belum lagi. Tak ada plate monitor use for this. 4K, 8K mungkin dah ada TV kan? Right? Okay, the second one is scientific application. Sequencing of human genome, analyze biological sequence, etc. Right, so for scientist nak gunalah. Alright, so tambah-tambah dekat aerospace, in aerospace environment kan. Right, so to analyze whatever, so we need the parallel computing. Okay, the third one is commercial application. Like we see before, kan ada untuk commercial. Kita mungkin guna untuk e-commerce, data mining, data whatever, big data, kan? Right. Wall Street dia tunjuk ni, Wall Street. And also in computer security, embedded system and etc. This is for application in computer system. So this is end of this chapter, I think. So you finishing the ebook. Can you finish it by today? Sikit je. Boleh kan? Alright. So 11.30 dah. Just stop. Tak tahu jadi lagu mana saya punya recording tadi. Alright, that's all for today. Any question? Okay, you can pass the question while you reading the ebook. So I'm waiting online. Saya start online tapi kita off our VC. So you can put the question in Mentimeter tak? Cancel. Ni dah cancel. Dah habis. Mana kita punya ni? Sini. Kamu nampak skrin saya lagi kan? Mana satu lagi ni? Oh sini. Ke sana ke sini, ke sana ke sini. QA for today. So you can put your question there. I will answer behind video conference lah. Okay, that's all for today. Don't forget to clock out. Boleh? Okay. I postpone this class with tasbih kifarah and surat wal an. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana fi khusr illa alladziina amanu wa 'amilus solihati wa tawassaw bil haqq wa tawassaw bis sabr. Sadaqallahu azim. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Thank you very much.
Sama-sama.
Thank you, sir.
You are welcome. Meeting tak boleh. Okay, and alright. you.